Good morning. I am Dr.P.Ranjith Kumar, Professor of Pcd Department, P.S.R Engineering College, Sivakasi. Today we are going to discuss about two-port networks. So, two-port network. So, I think all of you come across the word port. Port means what? So, in our computer system, we are having different type of ports: input port, output port, keyboard, mouse, parallel port. So, all the ports are available. Okay. So, what we are going to do? Okay. So, port may be getting inputs. Okay. We are giving some signals to the port and we are getting some signals from the port. Okay. So, port act as either input port or output port or bidirectional port. So, some port act as so it can be either act as input and output ports. So two-port network devices. A pair of terminals through which current may enter or leave from the network is called two-port network. So, two-port network means, so two terminals or elements such as resistor, capacitors are connected in series or parallel or any other combinations. So, finally, we will get some circuits. So, from the circuits, we are giving some input to the circuits and we are getting output from the circuits. For example, common emitter amplifier. So, we are giving input to the emitter circuits, common emitter amplifier circuits. We are getting output from the common emitter, collector output from the collector junction. So, this similarly transformer. So, we are giving some input to the 220 volt, giving 220 volt voltage to the transformer and we are getting 10 volt or 20 volt from the transformer output. So, these are the two terminal devices. So, next one is why it is essential. Okay. So, it is either unidirectional or bidirectional port. So, why it is essential means in our communication system we are performing some data transmission or data reception operations. So, data transmission or data reception operations. So, from which data is transferred from source to destination. Okay. Suppose if we are having mobile phone, so what we are having? So, in our mobile phone, microphone converts our speech signal into electrical signal. Again, electrical signal is converted into digital signal. The digital signal is processed and it is ready to transfer over the devices. So, what will happen? The digital signal is converted into again electrical signal, then the electrical signal is converted to electromagnetic signals, then it is sent to the base station of the communication systems. So, it is essential for all the things. So, suppose number of ports are increases. So, suppose we are having in our computer system we are having LAN cable. So, node has only 30 nodes or 40 nodes. Suppose if we want to increase our node into 100 systems. So, what will we do? We need to increase the LAN port. So, which is used for, so suppose it may be configured either serially or parallel to the systems. So, these are the linear network. So, one port network. So, one port network means we are giving just one input. Okay. So, suppose we are giving USB port means we are connecting only pen drive to the USB port. So, these are the one port network. So, we did not get any output from the pen drive port. So, two port network means suppose we are giving some input to the some CD, okay, DVD system. Okay, we are giving DVD to the input port of the system and we are getting output. Okay, DVD output means we are getting some movie, song. So, everything is possible in the two port network. So, two port, why we are choosing two port network means, so it is mainly used in communication, control system, power system and electronic systems. So knowing the parameter of two port network which enable us to treat black box when it is embedded in larger. So, what is the meaning means, suppose if we are converting our system into, so we know the port is available. So, it accepts only input and receives data and sending data and receiving data from the communication channels. Suppose why we are analyzing two port network. So, next one. So, we can observe that there will be initial state. So I1, I2, these are the two currents and V1, V2. So input voltage current and output voltage currents. So which are independent through various parameters. So first one is Z parameters. Okay. So Z parameter means impedance parameters. So impedance parameter. So what we are going to do in impedance parameter means, so it is mainly used in synchronization purpose. So synchronization means, so suppose if you are sending some data to the source to destination, so receiver receives the correct signals or error free signals. Suppose if your impedance of the system, that is input impedance and output impedance are does not match with the entire signal, so what will happen? So we are giving some voltage, 0 voltage, 5 voltage means the receiver receives only 3.3 voltage or 4 voltage, or suppose if you are giving some 0 voltage means the receiver receives 1.1 voltage or 1.5 voltage. So these are the deviations are occurred due to impedance imbalance. Okay. So as to we have to identify the impedance of the any network. So input impedance and output impedance should be equals. So if it is equal means it is called as characteristics impedance. So characteristics impedance handles both input impedance and output impedance. So today we are going to discuss about input Z parameters. So it is the input impedance. So it is mainly used in synthesis of filters and used to design and analysis of matching of networks in power distribution networks. There are two types of network. So two-port network operates either in input driven or current driven. Next. So suppose we are having two-port network means, so we may connect either voltage source or current sources. So these are the circuit diagrams. So a black box which is replace the Z parameter which is shown in the figure. So there are 4 parameters already I was shown there. So Z11, Z12, Z21 and Z22. So Z parameter can be characterized as 2 equations, voltage equations, and Y parameter is represented as current equations. So Z parameter means V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 and Z22 I2. Next. So these are the matrix form representation. So first initially we are having I1 equal to 0. So I1 equal to 0 means input impedance equal to 0 and I2 equal to 0 means output circuit is open. Okay. Next one. So after getting we are having some results. Z11 equal to V1 by I1. Substitute I2 equal to 0 in both equations. So after that we will get Z11 equal to V1 by I1, Z22 equal to V2 by I2, and Z21 and Z12 are V1 by I2 and V2 by I1. So where Z11 is the open circuit input impedance and Z12, Z21 is the forward transfer impedance and reverse transfer impedance, and Z22 is the output impedance. So the forward transfer impedance and reverse transfer impedance should be equals. So if it is equal means, so the input impedance and output impedance of the circuit is equal. So we have to meet the characteristics impedance of the any circuits. So these are some example problem. So find the Z parameter of the given circuits. So port 1 V1 and we are giving input to the V1 and we are getting output from the V2. Okay. So these are the some general circuits. Next. So first one, initial solution I2 equal to 0. So I2 equal to 0 means we will get V2 is open. Okay. So the configuration is like this. Next one. So V1 equal to 120 IB. So I2 equal to 0 means we will get the equation I2 equation 0. So first equation V1 becomes 120 into IB and IB equal to back. So IB equal to like this. So 120 divided by 240 into 40. So total sum of resistance divided by particular resistance divided by total number of resistance. Next one. So 160 divided by 400 I2. Okay. So total number of resistance equal to 400 and particular resistance equal to 160. So substitute the value in the particular equation, we will get Z22 and V1 equal to Iy back one. Back. V1 equal to 120, Ib equal to 280 by 480. So substitute the values, we will get Z11 equal to 84 value. Similarly, Z21 equal to 72 ohm. Next, so is input port is open. So I1 equal to 0 and redraw the circuit. So I2 equal to open. Okay, so redraw the circuit means we will get 120, 240, 40. Next. So here total resistance equal to 400. So we will get 160. So after that, after substituting all the values, we will finally get the Z parameters 84, 72, 72 and 96. Now next one is Y parameters. So Y parameter is also called as admittance parameters. So the unit of admittance is Siemens. Okay. So Y parameter is also inverse of impedance parameters. Okay. Similarly, we are having input port and output port. So Y parameters can be represented in terms of current equations. So I1 equal to Y11 V1, Y12 V2. Similarly, I2 equal to Y12 V2, V1 plus Y22 V2. So for Z parameters, we are having voltage equation, and Y parameters, we are having current equations. So the same equation, linear equation, can be represented in terms of in matrix form like this. Next. So after substituting the values, so similarly V1 equal to 0 for short circuited and V2 equal to 0 for short circuited. For Z parameters, I1 equal to open circuited and I2 equal to open circuited. For Y parameters, V1 and V2 are short circuited. So that we will get the Y parameters values. So Y11 equal to I1 by V1. So for V2 equal to 0. So substitute V2 equal to 0 in the equation 1 and 2 in Y parameters. We will get Y11 and Y12. Similarly, V2 equal to 0 so we will get Y21 and Y22. So these are some example problems. So find the Y parameter of the given circuit. Next. So similarly, same. So first one is I2. Okay. So V2 equal to short circuited. We will get equation V2 equal to 0. So substitute V2 equal to 0 means we will get the equation V1 equal to 20 into IA. So IA equal to 5 divided by 25 by using voltage current law. So after substitute the value, we will get Y11. Similarly, we will get Y21 equal to minus 1 by 5 S. So similarly, substitute the value of V1 equal to 0. Okay. So V1 equal to 0 means port 1 equal to short circuited. So find the equivalent resistance and substitute the values in equation 3 and 4. We will get Y22 and Y12. So after that, we will find the final value. Y parameter value equal to 1 by 4 minus 1 by 5 minus 1 by 5 and 4 by 15. So minus 1 by 5 and Y12 and Y21. So both are equal. So forward resistance and reverse admittance are equal. Okay. So similarly, APCD parameters. So in network transmission lines, we are concentrating only on transmission side parameters. So we are having another input voltage and input current. So we go for APCD parameter. It is also known as transmission parameters. It is used to analyze the transmission lines because the expression we are having sending end variables and receiving end variables. So V1 and I1 and V2 equal to I2. So these are the general diagram of ABCD parameters, and general equation of ABCD parameter is like this: V1 equal to A V2 minus B I2, I1 equal to C V2 minus D I2. Okay. So inverse ABCD means we are having V1 and V2. Sorry, I1 and V2. Next. So the parameter of ABCD is like this. So in the parameter A, B, C, D, where A and D are dimensionless, B is connected with respect to ohm. Okay, it is represent impedance, and C is represented admittance. So it is unit of C is Siemens. So similarly, same way. Okay, I2 equal to 0. So equation, current equation is open circuited and voltage equation is short circuited. So after applying all the conditions, finally we will get A equal to V1 by V2, B equal to V1 by I2, D equal to I1 by I2, C equal to V1 by V2. The condition of network parameters is AD minus BC equal to 1. So similarly, same the way we have to find the transmission parameter of the following circuits. So similarly, I2 equal to 0, that is open circuited. So I2 0 means output port is open circuited. We will get the circuit after final circuit is like this. So V2 into 10 I1. So after substituting all the values, we will get A equal to 1.2. Similarly, V2 equal to 0. So second port is open, that is short circuited. So find the value of I2. Okay. So D and B value will be get. So final we will get 1.2, 6.8, 0.1, 1.4 for the transmission line equations. Next one. Thank you.